Good morning everyone. Myself Dr. Shashikant Goilkar, Professor Mechanical Engineering Department, Phenolics Academy of Management and Technology, Ratnagiri. At this point of time, we will discuss about the damping which is there in the vibratory system, any vibratory system. Here we will discuss different types of damping techniques or different damping techniques used generally in any vibratory systems. In earlier session we have seen that there is the equation of motion of any vibratory system, and we have seen that in such a equation of motion there were two terms only in earlier equation of motions, that was related to mass and spring. And since the excitation force in earlier session, we have seen that the excitation force is absent, so in that case it is considered as a free vibratory system. Now whenever we consider damping, then one more parameter comes into picture, that is the damping force. So the equation of motion in that case becomes inertia force plus damping force plus spring force. The summation of all these becomes equal to 0. That means the system remains in equilibrium. So here we are interested to focus more, we are interested to discuss about the damping, and that damping comes in terms of the term as Cx dot. So in such case the equation of motion is given as mx double dot plus cx dot plus kx equal to 0. Now what is damping? We can say that the damping is the conversion of mechanical energy of a structure into thermal energy. That means with the help of the dampers or damping devices, we are converting the energies, we are dissipating the energy from one form to another, and we are trying to achieve that damping force, or we are trying to create that damping force in any mechanical vibratory system. So it can be done in the form of conversion of mechanical energy of a structure into thermal energy, or otherwise in other cases we can also do the energy dissipation, which is also considered as, or which is also measured as structure's damping level. Another thing is that damping is very important with earthquakes, since it dissipates the destructive energy of an earthquake, which helps in reducing the damage of the building or big structures, constructed structures. In typically mechanical devices, in many cases these viscous damping devices are used, and these viscous damping devices provides resistance to motion with the help of a dashpot damper. In many cases damping is also achieved with air dampers, so there are air dampers also available in the market, in which the resistance is provided with the help of the air resistance, and in such cases the damping force is achieved or damping force is created, so that the vibratory system can be controlled effectively. One more thing is that in any vibratory system, when we talk about the control of any any vibratory system, we have almost three choices in our hand. That means like we can control the inertia forces, we can control the damping forces, or we can control the spring forces. So with the help of these three associated parameters in any vibratory system, we can have nice control on any vibratory system. So here our focus is towards the damping force, with which we can also have some control on any mechanical system. Further, if we would like to know about the damping, type of damping achieved in various systems and the associated damping devices. In such case, hysteresis damping is also one of the type of damping used in many devices. In that, in those devices, the damping is achieved with the help of hysteretic losses into the material of the material present into the dampers or damping devices. Another thing is that viscous damping is also achieved. Viscous damping is also one of the type of damping which we can achieve, and these are in the form of tuned viscous dampers. Oil dashpot dampers are also there. Many of us are familiar with those kind of dampers, which are known as tuned viscous dampers. Again, damping is also can be also achieved with the help of interfaces. So the sliding interfaces of components of a vibratory system also can lead to damping force, generation of damping force or generation of damping. One more, now in recent technologies, there are different damping types. These damping types are emerging out, like active damping, which is nothing but the electromagnetic damping actuators or devices. In such system, the active damping is achieved with the help of the electromagnetic damping actuators and devices. One more thing is there, that is known as semi-active damping devices. So in that cases, advanced variable damping devices or dampers which uses smart fluids like electrorheological or magnetorheological fluids. These kind of smart materials are used in such kind of semi-active damping devices, and the damping is also achieved. And another thing is that the passive damping, which is nothing but the shock absorbers, in which the damping is achieved due to the viscous resistance amongst the within the fluid which is used into the dampers. So these are general types of dampings and the illustration about the damping devices which we can use to achieve this type of damping. Thank you very much.